All right, welcome everyone. So this particular lesson we are going to be simplifying rational expressions. So let's begin. I know that some of you got through all the notes, some other classes didn't get through all of them, got through part of them, but anybody can watch this to help yourselves review. So let's go on. And whoops, there we go. Okay, we're going to skip the 5-minute check. And so what we're going to be doing here, in a previous lesson, you simplified radicals. We've actually been working on that a little bit. And so now what we're going to be doing is we're going to simplify radical expressions by using the product property of square roots and simplify radical expressions by using the quotient property of square roots. You'll find that both of those properties look familiar because we worked on them when we did polynomials. So moving right along. Okay, our vocabulary is we're going to talk about radical expressions. We're going to talk about rationalizing the denominator, and then we are also going to talk about the conjugate. And that's how we get radicals off the denominator of a fraction, because that's a no-no. So let's go ahead and begin. Okay, so then our first step is here, it's the product property. Basically what you see here is whoops, sorry, that was a little sensitive. Going back, if you have AB multiplied underneath the radical, product property says you can separate it out. So you square root of A times B can be the square root of A times the square root of B. They both have to be positive because we haven't gotten to imaginary numbers yet. That's much later on. And then you see an example of where they had 4 times 9. So it's the square root of 36, which is 6. Okay? Or 4 times 9, you square root of 4, square root of 9, gives you 2 times 3, which is 6. So notice they're both 6. This is an example of putting it together. This is an example of doing it separate. Okay, so let's do one. Now, none of your calculators, because I've already checked, will just let you plug it in and simplify it for you. It's going to evaluate, so it's going to give you a decimal number if it's not a perfect square. I'll be honest, there is one calculator that'll do it. It's the Casio, like what I have, the color one, but none of you have that, so I don't have to worry about that. So you're going to have to be able to do this on your own. The other thing you're going to have to know is, guys, you got to know your factors and you need to know your perfect squares. On my SchoolFusion page, there is a PDF copy of a table of squares. So if you want to print it out and use it, you're more than welcome to. If you print it out, I would highlight all the perfect squares. Those are the ones where if they take the square root, the number ends in all zeros. Okay, so it's like square root of 16 is 4.00000. Okay, so here we have the square root of 52. Now, what you want to do is when you break your numbers down, the example here, they actually do all primes, but you could also do it where you are breaking it down just looking for perfect squares. That's actually what I do. And if you're familiar with your perfect squares, that's going to work out really, really easy. So just a heads up for you there. So let's go, and I'll show you this, and then I'll show you a different way to do it, but it's the same thing. Okay, so square root of 52 breaks down into 2 times 2 times 13. Well, what you notice is that 2 times 2 is 2 squared, or 4. 4 is a perfect square. Also, if you leave it this way, this square root cancels this 2. So when you do that, you end up with just 2. Now, once you take the square root, the radical comes off, so you don't keep doing it again. So now we have 2 times the square root of 13. Square root of 13 does not simplify. It is a prime number. It's not going to break down. Okay? So then to simplify that, you're going to get 2 times the square root of 13. And that's it. Okay? Now, another way that I would have done, that I did this when I did it, if you play cards and you know all about how a deck of cards works, you should be familiar with that because you'll see that again in Algebra 2 and after, depending on which one you take, one or both. But I know that there are 4 suits in a deck of cards because there are 52 cards. I also know that means there's 13 cards in a suit. So what I did is I just do 4 and 13, square root of 4, square root of 13. Square root of 4 is 2, so 2 square root of 13. And notice you get the exact same answer that they got doing it the other way. Either one is fine with me. Just do whatever is comfortable for you. Okay? I honestly have no problem with that. So let's clear this. Okay. And let's do another one. Okay. Okay, so now this one is square root of 45. You should try that. Again, you need to know your factors. Okay, so pause it at this point and work on it. And then what I'm going to do is basically square root of 45 square root of 9 times 5. If you came up with something else, remember what we're looking for is perfect squares, okay? So square root of 9, square root of 5, square root of 9 is 3, so 3 square root of 5. So our answer should be B, okay? And then if we change that, and that's exactly what they got. So we did good, okay? Moving on to the next one. Okay, now what we're doing here is, this is actually using the product property. So notice that they're separated out, but you can also put them back together. A couple of ways again for you to do this. For me, what I would have done is I would do 2 times 24. When I break up 24, I know that 24 is 6 times 4. So 6 and 4. Well, I have a perfect square here, but I can break down 6. So 2, 2, 3, 4. Okay, here's the 2 that you started off with, and then here's the 6, and here's the 4. Now notice I can write this as 2 squared times 3 times, whoops, sorry about that. Go back. Times 4, which means I can write, I'm just going to go up here with it, square root of 2 squared, square root of 3 times square root of 4. So remember, it's square root of 2 squared. The square cancels out the square root, so that's 2 square root of 3, and square root of 4 is 2. And then what you do is you multiply the numbers out front, so you're going to have 4 square root of 3. Okay. If it helps, let me rewrite this, and that might make it a little easier. So 2 square root of 3, 4 square root of 3. Okay. Now, pause it if you want to copy this down, or you can rewind it. Now, I'm actually going to show you what they did, and you'll see it's the exact same answer. So here's what they did. They break it all down till it's all primes, and that's okay too. Okay? And then they put them in groups of 2. So here's 2 squared, here's 2 squared, square root of 3. Okay? Square root of 2 squared is 2, square root of 2 squared is 2, and square root of 3 stays. So you end up with 4 square root of 3. Excuse me. Okay, let's do another one. Again, please feel free to pause or replay or whatever you need to do. Okay, now this particular one, what we're going to do here is I'm going to break it down. So I'm going to do 5 times 35. And if you'd rather pause and work on it yourself, please go ahead. Pause right now, work on it, and then replay. So I have 5 times 7. The 5 times 7 is the 35. Okay. So square root of 5 squared times 7. So this is the square root of 5 squared times square root of 7. This cancels, so we'll get 5, and this is prime, 5 square root of 7. So our answer is A. And let's see. And that's what we got. Perfect. We're doing great. Okay, so next one. Okay, so now here what we're doing here is we're just going to be breaking up the variables. So what you want to do here is you basically, if it's an even power, just cut them in half. Okay, so I'm going to show you how they do it. Now we've already done square root of 45. We already know what that is, but I'm going to walk through that real quick. All right, so here you have 3 squared, which is your 9, remember, and 5, and then a to the 4th, b to the 5th, c to the 6th. Okay, now notice we separated everything out, which is fine, okay? But notice on our b to the 5th, we have a b to the 4th and then a b. Because again, you want the power to be even so that anything that's not even will stay under the radical, okay? So when we do that, this is 3, this stays. Half of 4 is 2, so a to the 2nd. Half of 4 is 2, so b to the 2nd. This stays underneath the radical, and then half of 6 is 3, so c to the 3rd. Now they put absolute value around because you want to make sure that your answer is positive. I'll be honest, if you forget the absolute value, I'm not going to beat you up about that. So now everything that we pulled out is going to go out in front, and then we're going to combine the two that are still underneath the radical. Okay, so here's our 3, our a squared, our b squared, our c to the 3rd. And then underneath is 5b because you just multiplied those two back out. Okay, and that's what we're going to do. So let's do the next one. And there we go. Okay, so now we're going to do 32. And now, one of the things I did is I looked at it, process of elimination, but let's do it, okay? So 32, most of you probably said 8 and 4. 8, 4, m squared, n squared, c. But 8 also breaks down into 4. So 2, 4, 4, m squared, n squared, c. So this is going to be square root of 2, square root of 4, square root of 4, square root of m squared, square root of n squared, square root of c. Whoops, c. Okay. So I'm going to pull out my perfect squares. So there's a 2, and there's a 2. So I'm going to take my little highlighter, and I'm going to cross off the ones I've done. Okay. Here's a perfect square, and here's a perfect square. Okay. So then this is going to be m and n. And then underneath my radical, there's a 2, and there's a c. So I'm going to have 4mn square root of 2c. These have exponents of 1, so that's why I put an absolute value. So my answer should be C. And let's see what we got. And we are right again. Okay. There we go. So now let's go to the next one. Okay, now just like we did the product property where it's together, we're going to do the quotient property. So if it's the square root of a over b, we're going to do square root of a over square root of b, or divided by. Okay, so we're going to do the same thing. Only now, one of the things you have to remember is we can't have a radical in the denominator of a fraction. So this is going to need to be simplified because we can't leave that square root of 8 down there. Okay, so this is a standardized test question, so you're going to read the question. Okay, and then we're going to solve it. Okay, and what we're going to do here is we need to get rid of this square root of 8. So we're going to multiply top and bottom by square root of 8. When you do that, you multiply underneath the radical. So 3n times 8 is the square root of 24n. Square root of 8 times square root of 8 is the square root of 64, but the square root of 64 is 8. So if you multiply in the square root times itself, the square root just falls off. Okay? Now we're going to have to clean up the top because I know there's a perfect square in 24 because we've done it. Okay? And so there's 2 times 2 times 2 times 3 times n. Notice the 8 stays on the bottom. Okay, so we're going to pull out the 2, and that leaves us 6. So here's what they did, just a heads up. So you're going to have 2 squared times 6n. Okay, and so that's going to be 2 square root of 6n, because you do these separately. Okay, that's how they got that. All right. And then, so what happens is they reduce this 2 over 8 down, just to give you a heads up. That's what they did. And that's how they got 1 over 4. And that's how they got their answer. Okay? So anything outside the radical, you can simplify, but if it's under the radical, you can't do that with something that's not. So in our answer, when we look back to our problem, the correct answer should have been D. So that was it. Okay? Let's clear that. And let's move on. Okay, guys, I don't think we have much more to go, so you're doing okay. Okay, so now here, let's do this one where we simplify this one. I'll be honest, versus multiplying, well, you can do 27. I guess it's not a big deal. So let's do it that way, okay, because it's going to be square root of 2 over square root of 27. I'm going to multiply top and bottom by square root of 27. So what you do is you look at the bottom to decide what you're going to multiply by. When you do that, you get square root of 54, because 2 times 27, okay? And that's over 27, okay? But I happen to know that 54 is 6 times 9 over 27. Square root of 6, square root of 9 over 27. 3 square root of 6 over 27. 3 over 27 reduces down to 1 over 9, so we're looking at square root of 6 over 9, okay? This is your answer. You can eliminate this one. Why? It has a radical in the bottom, and that's not even close. Okay? So that one's an automatic no-no. And then the other two was just figuring it out what you did. So what I did is I multiplied top and bottom by the square root of 27. This became 27, and then I simplified the top. Okay? So hopefully you'll get some practice doing that. And doing the homework is going to be so important here because that's how you're going to get your practice. Okay. And there we go. And we got our answer. Okay. Now, here using a conjugate to rationalize the denominator. So what you want to do here is you want to get rid of this radical. But in order to do that, you have to get rid of this whole thing. Okay? So what we're going to do, this is called, the conjugate is the opposite. So see, the conjugate of 4 minus the square root of 5 is 4 plus the square root of 5. So the only thing you do different is you change the sign. If this had been a plus, you would do a minus. If it's a minus, you do a plus. Okay, so then what we do at that point, you're going to multiply. This is a difference of 2 squares, okay? So basically you're going to square the first number and square the second number with the minus, okay? So if that seems a little too confusing, my suggestion, use the box. And I'll show you that. So when you do the box, it's 4 minus square root of 5 and 4 plus the square root of 5. 4 times 4 is 16. This is 4 minus 4 square root of 5. This is 4 square root of 5. And then this is minus 5. Okay? Notice these two are exactly the same. Okay? Hold on just a minute, guys. Okay, so what I did is I just used the box. And so what you end up with here is you have 16. These cancel because they're the same except for the signs. And then you're going to subtract 5. So that gives me 11. Okay. And again, I'm going to have to pause for just a minute. All right, everybody. Had to stop for a minute, but that's okay. Okay, so you end up here with your 16 minus 5 because these two cancel. They always cancel. So basically you take 4 times 4 again. I'm sorry, 4 times 4, and then negative square root of 5 times positive square root of 5. That's where they got that. Okay? And then the top is just 2 times that whole thing. Okay? So there you go. And you end up with 16 minus 5, which is what I got right here. Then you are going to subtract that, and it's simplified, and it's done. Okay? That's it. I mean, because square root of 5 times square root of 5 is just 5. And that's how you do the conjugate to rationalize the denominator. Notice that you use that when you have more than one term. So let's do this one, and I'll help you along with this one. And so what you're looking at here is you have, what we're going to do is multiply times 3 plus the square root of 5. Okay, so you're going to have 4 times 3 plus the square root of 5. On the bottom, you're going to have 9 minus 5. 3 times 3 is 9. Square root of 5 times square root of 5 is just 5, so minus that. Okay, so what you're going to have then is you're going to have 4 times 3 plus the square root of 5 over 4, because 9 minus 5. But notice what? Your 4's are going to cancel, so your answer is just going to be 3 plus the square root of 5. That's what we should get. Okay? And there you go. Got it. You're all done. Okay? So let's clear that, and let's go on. And we're done. So there are your notes. Please just practice. If we have to spend an extra day on this lesson, I am totally good with that. Okay? But your homework is posted on School Fusion, and I also wrote it on the board. Okay? And I'll see you on the next video.